Hi, it's Mrs. Green, and this lesson is surface area of cylinders. So we're still talking about surface area, what it would take to wrap a figure, or how much material it would take to build the entire figure. So if you think of a can, the typical shape of a cylinder, how much metal would it take to make a Coke can, that kind of thing. Okay. So you're going to put in your prior knowledge, and so we do have quite a bit of prior knowledge now of what surface area means, and we've just changed the shape. So instead of a prism, now we're talking about a cylinder. So the three things I want you to focus on for a cylinder, first of all, making the net. If you imagine on this can of Fanta that you could cut the label off, let's say it's a paper label, and you cut it down the middle, and you peeled it, you would have a rectangle. So it might surprise you to find out that the net of a cylinder is two circles, the top and the bottom, and then the middle part is actually a rectangle. So if you imagine it's a label, like on a soup can or this Fanta can, it ends up being a rectangle. And so that's what the net looks like. So please draw a net of a cylinder. Then the definition of lateral area, that is any 3D shape, but it starts to become very important with a cylinder because it's the area without the bases. So in this case, it's that rectangle, the label that we're talking about in the cylinder. So the lateral area is all the area except the bases, without counting the bases. So in a prism, that would be that part, that's that middle part. So without the bases, you don't count the bases, it's this middle, all the area of all the other faces added together, lateral area. Okay, and again, this is optional formula for surface area of a cylinder. Surface area equals 2 times the base. That's exactly the same as any prism. I'm sorry, that's the area of the base. Plus, in prism we had perimeter times height. Because we have circles here, we have circumference times height. So let's just define down here, B, capital B is base area. That's the area of the base, so we have to calculate the area of one of those circles. C is the circumference of the base. So that's just like the perimeter in our prism, it's the circumference because these are circles. And then height is the distance between your bases. So height is still the same. H is the height. Same definition. So we can substitute in the formula for area of the base, which is going to be pi r squared, and circumference of the base, which is 2 pi r. So that formula just got a lot uglier, but all we did was substitute in the two area of circle and circumference of circle, which you know from the last unit. Okay, so that's you can write either one of these. This is an equivalent form in red of the black. All right, example problems. Okay, here's an example of a can that's 10 centimeters high and 8 centimeters in diameter. And we don't know what's in this can. Okay, so mystery meat. Doesn't have a label. Okay, so I'm going to draw a net. And I know that my rectangle is 10 centimeters high by the circumference of my circle. The circumference is going to be 2 pi r. And then the area of my circle is going to be pi r squared. So I can calculate the area of my top and my bottom. So my top is going to be pi r squared. So that's going to be, radius is 4, and pi is 3.14. And then that's also going to be the same as the bottom. So I'm going to add those two together once I calculate them. So both my top and my bottom are 50.24 centimeters squared. So that's the area, both of those. I have one too many points in there. 50.24. So I have to double that. I have to keep track of both of those, the top and the bottom. And then the label, the lateral area, this rectangle is, let's say lateral area, that's 10 times my circumference, which is 2, oops, let's see, 2 times pi, and my radius I figured out was 4. So that's going to be 10 times 8 times pi, so that's going to be 80 times pi. So that's going to be 251.2 centimeters squared. Now I have three parts to add up, the top and the bottom, which are the same, and the label, or the lateral area. If I total all those up, I get 351.68 centimeters squared, or 352 rounded off centimeters squared, units. For my can, that's how much aluminum it would take, or that's actually looks like I'm not sure what metal that is. Tin, I think, tin can. That's how many centimeters it would take to make that can, top, bottom, and lateral area. If you just wanted to figure out how much it would take to make a label for that can, since it doesn't have a label, that would be the lateral area without the bottom and the top, which we know is 251. So that's kind of a, that might be something someone asks because that's normal, that you would put a label on it without needing the top and the bottom. Okay, practice problems are 14 and 15 out of the blue textbook from page 577. Again, draw a net, practice that, and then find the surface area of each of these cylinders. And they give you instructions to round to the nearest tenth because you're dealing with pi. You have to round somewhere. So they're nice enough to give you those instructions. And then do your wrap-up summary. Signing off.